So question 7, we have been told that we have L1, the position vector R equals negative 2I plus 3j plus lambda into 3I minus 5j. And we have now position vector L2, such that you have here R1 is R2 equals to 3I plus j plus mu into 2I plus j, when mu and lambda are constant. We are being told to find the position vector of the point of intersection. To find the position vector of the point of intersection, it therefore means that at that point R1 is equivalent to R2. And we see that here we can write in this form. We can write each of this in this form. I want to have something like this: negative 2. I take I components to be a negative 2 plus 3 lambda. I put it up. The second component I have 3 minus 5 lambda equals to the same thing. I have here 3 plus 2 mu. Then I have also here 1 plus mu. Okay, so I have now a set of simultaneous equations that I have to solve to find the value of lambda and mu. So I discovered I have 3. I can arrange this to 3 negative 2 plus 3 lambda equals to 3 plus 2 mu, which gives us 3 lambda minus 2 mu equals to 5. And then similarly I have 3 minus 5 lambda is equals to 1 plus mu. This is the same thing like saying negative 5. Well, let us take it like this. It's going to give me 5 lambda minus plus mu equals to equals to 2 rather. Because if I take this way, I'm going to have negative 5 lambda minus mu and then negative 2. So I multiply all by negative. So I can multiply this equation by 2 to do the elimination, to solve it by elimination method. I'm going to have here 10 lambda plus 2 mu equals to 4. So I can add both equations to eliminate mu. So I'm going to have 13 lambda is equals to 9. So lambda equals to 9 on 13. And similarly, if lambda is equals to 9 on 13, it therefore means that since mu is equals to 2 minus 5 lambda, it means that we're going to have mu is going to be 2 minus 5 on 9 times 13. On 5 times 9 over 13. I'm going to continue that way. So we're going to have here mu is equal to 26 minus 45 on 13. And 26 minus 45 will give us negative 19 on 13. Negative 19 on 13. So the values of lambda and mu. So to get the position vector of a point of intersection, you need to come and replace either lambda in the first equation or mu in the second equation. So I'll take the second equation and replace the value of mu. So it means R, the position vector where they intersect, you have 3I plus j plus mu. Mu is negative 19 on 13 into 2I plus j. It's going to give me 3I plus j minus 28I on 13. Then I have here minus 19 on 13j. So I can look for the LCM. I can bring the items together. I'm going to have 39 minus 28 giving me 11I on 13. And I have j. I'm going to have here 1 minus I'm going to have negative 6j on 13. So that's the position vector of the point of intersection of 2 points. So each time you want to find the position vector of the point of intersection, the idea behind it is to equate the two expressions. Where you have, after you have put the terms in I together, terms in j together, bringing items together and solve the simultaneous equation. Okay. Now I want to continue to find the cosine of the angle between the two lines. The cosine of the angle between the two lines. We all know that a line, to find the angle between two lines, we make use of a formula Now we have A dot B. Well, let me say B1. Let me take it this way. So I have B1 dot B2, that's the scalar product, because B1 magnitude of B1 magnitude of B2 times cos of the angle between them, theta, where theta is the angle between them. And here yes, B1, every line is written in the form R equals to A plus lambda B. So the B we're talking about, that means R1 is A1 plus lambda B1, R2 is equals to A1 plus lambda mu B2. So this is what we're going to have. It means that B1 in this our case will be 3I minus 5J, and B2 is going to be 2I plus J. So I can now do the dot product. So B1 dot B2 is going to be, I'm going to say will be 3 times 2, that is you multiply the I components together, minus 5 times 1. So it's going to give us here 6 minus 5 equals to 1. And then also the magnitude of B1. To find the magnitude of a vector, you just square the component. You square the component, that will be the square root of the magnitude of B1 will be 3 squared plus negative 5 squared. So it's going to give me 9 plus 25. 9 plus 25, which is 34. And then I have also the magnitude of B2, which is equals to 2 squared plus 1 squared. So give me the square root of 5. So here is the square root of 34. And here is the square root of 5. So from there, I can proceed to find the angle between them. To find the angle between the two lines. Okay, we can proceed to find the magnitude of the angle between the two lines. Okay, we are being told to find instead the cosine. So cos theta from there is equals to B1 dot B2 all over B1 magnitude of B1 magnitude of B2, which is equals to B1 dot B2. So that's giving us 1, and then we have magnitude of B1 was root 34. And the magnitude of B2 was root 5. So it's going to be 1 over the square root of 5 times 34, which is 20. So I'm going to have 34 times 5, giving me 20. And I'm going to have here 15, 170. So it's going to give me over the square root of 170. So that's the cosine of the angle between the two lines. Cos theta is equals to 1 over root 70. Or some people can rationalize by saying it's 170 over. It is root of 170 over 170. Okay, now I'm going to move over to the last question. Okay, in this question I've been told that y is equals to 5 minus 2x to the power 4. Okay, we should find dy by dx. So first of all, we're going to make use of the chain rule. The chain rule says that we should equate this one equals to u, and then we're going to find dy by dx. Remember that the chain rule, it means that let u be equals to 5 minus 2x, and therefore to get the du by dx is simple. It's going to give us negative 2, and then also we know that dy by dx is equals to dy by du times du by dx. So we can also calculate du by dx. It therefore means that the y here, in this case, it means that y is equals to u to the power 4. And if you get dy by du, we're going to give us 4u cubed. So if I have to use this formula listed above, I'm going to have dy by dx will be dy by du. Dy by du, which is 4u, and then now times du by dx, which is negative 2. So it's going to give me negative 8u cubed, which is the same thing. But u, initially u is equals to 5 minus 2x. So I'm going to have negative 8 into 5 minus 2x, all that to the power 3. Okay, now we're to the last part of the question. We're having the integral. We're having us to find the integral from 0 to 2 of x plus 2 plus 1 to x. There are two methods to do this, but then we're going to use the easiest. The first one, you can recognize that this is a square, that's x plus 1 all squared. But then, see it is given like this, we can just integrate. You know, integration is distributive over addition. So, therefore, means this is equivalent to the integral of x cubed on 3 plus 2 plus x squared plus x. So, we have this is what we have. So, the boundaries are 0 and 2. So, when we place 2 this way, we are going to have 8 on 3 plus 4 plus 2 minus 0. So I'm having 8, this is 6. So I'm going to have 8 on 3 plus 6, which is the same thing like 18 plus 8. 18 plus 8 is 26 on 3. So the value of that integral is 26 on 3. So that's all for the video. Have a nice day and take care of yourself.